Today we'll be making a part counter. It refreshes every 20 seconds and the user can manually refresh by clicking on the display. This is all possible through CoreGui. CoreGui is a container for all your plugin's graphical components. Lua widgets are great for making panels of controls and settings, but sooner or later, you'll want to add something embedded in the game window. CoreGui will help you do just that, so let's get started. Now, in every tutorial up to this point, we've started by adding in a local script. However, for the first time in history, we will start by adding a screen GUI. Yes, please hold your applause till the end, thank you. Next, we'll drop in a text button, and I'm sure you saw this coming, we're still going to drop in a local script. Let's start by arranging our graphical components. So we'll go to the Properties panel and select Screen GUI. For now, we can just name it Part Counter. We don't have to worry about any of these other properties at the moment, so we can move on to the text button. We'll change the name of this to Display. Now you can design this however you want, then at least be using the code font at size 18 with the height of 20 pixels. And you should also set the text alignment to left. Pretty much the rest of the settings aren't really necessary, but if you'd like to copy mine directly, you can. So I'll turn on clip descendants, set the anchor point to 0, 1, and set the position to 1, -5, then x is also -5. Correction, x is 5. I'll also set the border size pixel to 0, since I don't like seeing the borders. And finally, I'll clear the text and set the x size to 0. Now you might say, why would you make it 0? That'll make it invisible. Well, in our code, we're going to make it so it's visible. We're also going to do one more thing. See this label? We're going to disable it. Don't worry, we'll enable it later in our code. It's generally a good idea to keep your plugin interface disabled. That way, if you're testing your plugin in the same environment you're developing it in, you won't get confused by which one's which. So now let's head over to our script. We'll start by referencing our interface, which is just script.parent. Next, we'll reference the display button. We'll use the wait for child function in case the loading process is delayed. Next up, we want to put our interface into the core GUI so the user can see it. And we can do that by changing the interface's parent to game.coregui. This is also the point in time where we enable the interface. Now, believe it or not, this is a fully functioning plugin. You could publish this, provided you change this object to actually be visible, and you would be able to view it in the window. However, we can take this a step further and actually add some functionality to the button. Let's start by adding a function that calculates the amount of parts in an object. We'll call this function countParts. Now, obj is short for object. We'll be looking through this to find all the objects inside of it that are parts. We'll create a variable for keeping track of the total amount of parts in the object. And we know we want to return the amount at the end, so we'll put in return total. Now in between these two lines, we want to add a loop. Now that we have a pairs loop, we want to add what we're looking for. So we'll put in obj, and then we'll use a function called getDescendants. This is better than the getChildren function, since it will also get the objects that are inside those children and so on. Next, we need to check if the object is actually a part. Now we could check the object's class name and see if it's equal to a part. However, that would limit our function to only detecting absolute parts. Our function would be limited and wouldn't cooperate with things like truss parts and wedges. So instead, we can use an if statement and use the isOf function. Any brick in the game will be labeled under base part. Now if it is a base part, then we can increase the total. And now we have a function to count parts. So now we'll create another function. We'll call this one updateCount. Job of updateCount is to do exactly what it sounds like. It'll refresh the display to change it to the current brick count. So we'll start by getting the total bricks in game.workspace and game.server storage, like so. Now you might be asking, why are we only doing workspace and server storage? What about lighting, or replicated first, or replicated storage, or server script service, or starter GUI? And the reason is, if you're putting parts in lighting, you shouldn't be doing that. There are other places to put parts. Ultimately, it comes down to accuracy versus performance. Do we really want to run through this function one extra time? The amount of resources that get used from this will add up over time, and it's a good idea to preserve as many as you can. So for now, we'll just do workspace and server storage. Next, we want to change the text on the display. So we'll do display.text and equal that to a string version of the total. We'll tack on the word parts on the end to let the user know what it's counting. And now we're going to change the display size. So we'll set display.size equal to a unit called udim2, which can be created with the new function. Now this function's pretty much identically to position and size, and since we're changing the size, we can base it off of this. We know we want the scale to be 0 since we'll be operating in pixel measurements. Now if you chose the same font type and size as I did, you know that the text size is 18 and the font is code. Now through some trial and error, I figured out that the average size for the code font is about 9 pixels wide. So we'll type 9 pixels times, put the pound symbol to get the number of display.text. And vertically, we want no scale, and we want 20 pixels. So now we need to use this function. In the triggers section, we can add display.mouse button 1 click connect to update count. And we'll also make a permanent loop that runs every 20 seconds. And we'll just add the update count function in there. We also want to update the count on startup so they can see what the amount is as soon as they get into the game. However, if we try to execute this at runtime, it might slow down the loading process. So we'll wait 3 seconds to give the game enough time to load properly, and then we'll call update total. So now let's export this. We can close the script for now, and right-click on part counter, and publish this plugin the same way you would a script. Well, it appears I made a mistake, because the interface never loaded down here. And I suppose this is a great moment to teach you how to correct errors in a plugin. It's pretty simple. The output will tell you what the error is. So you can see, attempts to call global update total, which is a nil value. So it means I tried to call a function that doesn't exist. So if I go into our script, you can see I call update total on line 31, but the function name is update count. This is what happens when your brain is on autopilot. So I'll change this to update count, and I'll be right back. So I'm back in the game, and here is our interface, and no errors, fortunately. Now if we click on it, we can see it stays exactly the same because we haven't removed any parts or something. So let's go into workspace, delete guy, and then click on it. Oh, I didn't even have to click on it, automatically refreshed. But I can do Control Z to undo that, add the part back, click on this again, and it changes 8,019 parts in this game. Wow, I need to work on optimization. So that is how you use CoreGui, and I hope that was helpful. See ya.